Assalamu alaikum. In this video, we will talk about equilibrium of rigid body in 3 dimensions. First of all, I want to talk about the equations of equilibrium here. We have 6 equations. Sigma moment about x equals 0, sigma moment about y equals 0, and also about z equals 0. And all summation of all forces in all directions also will be 0 because the resultant force is 0 vector and also the resultant moment is 0 vector. So we have 6 equations and we can get 6 unknowns. Second, we want to talk about the supports and reactions. Look at this table. Exactly in this video, we will talk about the first type here. For each support, as I told you before, you should know the name of the support and the shape of the support and the type of reactions at this support. The first support here is called ball and socket joint. Ball and socket joint. We call it ball and socket because it consists of two parts, as you see here. This is the socket, okay, and this is the ball. We have a rod. At the end of this rod we have a ball and we put this ball at this socket. In this case we can catch the rod here and move it in all directions at this point. So the type of reaction will be a force with unknown magnitude and unknown direction, and we prefer to resolve it into 3 components: x, y, and z. So if we have a ball and socket joint at point like A, we should know that we have AX, AY, AZ for the reaction at this ball and socket. Let's go to the examples. Question number 1. The cable CED can sustain a maximum tension of 800 pounds before it fails. Look at the cable here, CED, through this pulley. Determine the greatest vertical force F that can be applied to the boom. Also, what are the X, Y, and Z components of reaction at the ball and socket joint A? Okay, very good. So the required here is AX, AY, and AZ, and also the magnitude of F. We will solve this problem in 4 main parts. Number 1 is the free body diagram and the coordinates. In the free body diagram, we should show all the forces act on the body, which is this rod. We have here force F act at this point called G, and we have here the point B at which we have tension at B here in this cable here, and also we have the components of reaction at the ball and socket joint AX, AY, and AZ. The coordinates of G is 0, 5, 0, and the coordinates of B is 0, 10, 0. But the question now, how we will get the tension at B here? As I told you before that for each chord we have 2 equal tensions in opposite directions like this, and I will call this tension is T1 and this is T2, and we have here also TB, and this TB is equal to the magnitude of this tension, which is equal to the resultant of these 2 tensions. Okay, so my strategy is to get T1 as a vector and T2 as a vector and get the resultant. The resultant is the same as TB. To do this, let's get the coordinates of E and coordinates of C. Coordinates of C is very easy. 5 with Z and -4 with X. Right? To get the coordinates of C here, we can write C is -4, 0, and 5. But what about the coordinates of E? To get the coordinates of E, E is in the YZ plane. So its X coordinate is 0 and its Y coordinate is 10 minus 2. This is the 10 and this is minus 2. So the X coordinate of E is 0, Y coordinate of E is 8, but the problem is in its Z coordinate. If you complete BE here, if you complete this line, you will reach this point, right? So look at this triangle, please. BA and this point. BA is 10 feet and A to this point is just 5 feet. So you can say that the opposite of this angle, is half of the adjacent. So we can make a ratio which is 1 to 2. If we have here 10 feet, we have here 5 feet. So if we have here 2 feet, this distance should be 1 foot, okay? 1 foot. So the Z coordinate is 1. Number 2, all forces. First force, of course, will be the reaction at the ball and socket joint. A vector will be AX, AY and AZ. The second force can be written as F vector. I call it F at G. This is the second force. It's very easy. It will be 0, 0, and minus F. T1 vector can be written as 800 as a magnitude multiplied by its unit vector, which is from E to C. We have here the coordinates of E and the coordinates of C. So EC means C minus E, which is minus 4, and then minus 8, and then 5 minus 1, which is 4, divided by the magnitude of this vector, which is 4 root 6. So we can simplify 4 with 4 and write it as T1 vector is equal to 800 over root 6 multiplied by negative 1, negative 2, and 1, negative 1, negative 2, and 1. Also, if we look at T2 vector, from similarity, T2 vector will be the same as T1 vector, except in the x component, it will be in the opposite direction, because the coordinates of C is negative 4 as x coordinate, and the x coordinate of D is, so we can take the same as T1 vector, but in the first component it will be positive 1, and here minus 2, and here 1. TB now is the resultant of these two forces, so the y component and z component should be doubled, but the x component will be 0. Again, if we will add them, 1 minus 1, we can take 800 over root 6 as a common factor, and then negative 1 plus 1 will be 0, negative 2 and negative 2 will be negative 4, 1 and 1 will be 2. We can take 2 common factor, be 1600 over root 6 multiplied by 0 and then negative 2 and then 1. By this way we get the three forces. After that, the third stage is to apply in the equations of motion, which is sigma moment about the ball and socket point, which is A equals 0 vector. We have here two forces. The moment of the reaction at the ball and socket, of course, will be 0. So we have here RAG cross FG plus RAB cross TB vector is equal to 0 vector. We should have here two determinants. This is the first one here, I, J, K, and this is the second one here, plus IJK equal 0, 0, 0. We have three zeros here. The second component is for RAG, which is 0, 5, 0, and here for B, which is 0, 10, 0. Here is the force F, which is 0, 0 minus F, and this is the 1600 over root 6, and the components are 0 minus 2, 1, 0 minus 2, 1. It's clear that we can get sigma mx only equals 0. So we have here negative 5f plus, here we have 1600 times 10 minus 0, which can be written as 16,000 over root 6 equal 0. This means that f should be 16,000 divided by 5 root 6, which approximately equal 1306.39 pounds. After that, we can apply in the fourth part here, we can apply in sigma fx equals 0 to get ax. We should collect all the x component of all forces. We have here ax, but we have here 0, and also we have in TB 0, so ax should be 0. Ax should be 0. From sigma fy equals 0, we can write ay and then 0 in the fg force, but we have here minus 2 times 1600 over root 6 equals 0, which means that ay is equal to 3200 over root 6 pound. And finally we can get sigma fz equal 0, which we have az minus f, and then plus 1 times 1600 over root 6 plus 1600 over root 6 equals 0. By this way we can get the value of az. Okay, and then if we want to get the whole reaction at A, we can make square root x squared plus ay squared plus z squared. We have another way to solve this problem, but I think I prefer to solve with this techniques, inshallah. Okay, question 2, determine the components of reaction at the ball and socket joint at A okay, here, and the tensions in the supporting cables DB and DC, DB and DC. Okay, first of all, I want to illustrate our required here. Our required is to get AX, AY, and AZ. Also, we have to get tension at DB and DC. So I call them TB and TC. Again, we can solve this problem in 4 parts. The first part is the free body diagram. To save our time, I will draw the forces here in this shape. We have, of course, the ball and socket reaction, AX, AY, and AZ here. All these components are in one reaction force. And then we have TC, and also we have TB here. And we can replace this distributed load by just one force here. We can call this point E, and it will be 800 times 3 800 times 3 meter, which is 2400, or we can say 2.4 kilonewton. Let's also take the coordinates of all these points. The coordinates of A, of course, is the origin 0 0 0. The coordinates of D is 1 in X and 1 in Z, so it will be 1 0 1. The coordinates of C is 1.5 in Y and 1.5 in Z, so it will be 0 1.5 1.5. The coordinates of B should be 0 minus 1.5 and 1.5. Also, the coordinates of E is important here. E is 1 and 1 is 2, and we will put E in the midway here, so it will be 1.5 plus 2, it will be 3.5, 3.5 in X coordinate, and the Z coordinate should be 1.5, okay, 0 and 1.5. Let's now take the second part, which is all forces must be written in its Cartesian form, starting from the ball and socket joint at A. It has the components AX, AY, and AZ, and then we can talk about TB or TC, whatever. We can talk about TC now. Vector is equal to TC as a magnitude multiplied by its unit vector, which is DC vector over DC magnitude. DC vector is C minus D. It will be 0 minus 1 is negative 1, and then 1.5 minus 0, 1.5. Finally, 1.5 minus 1 will be 0.5. Square root of 3.5. From similarity, TB vector will be the same as TC vector, except in the y component, it will be in opposite direction, because it has the same coordinates except in y, okay? So it will be TB over square root of 3.5, and here we have negative 1 also, but negative 1.5 and then 0.5. Okay, finally we have the force at E, which I will call it F, okay, and finally F here, number 4, F vector should be 0, 0, and minus 2.4 kilonewton. The third part is sigma moment about A vector equals 0 vector. We have here 4 forces, but the moment of A vector is 0, of course, and so that we will have 3 moments, which cross FE vector. We have also RAD cross TC vector plus RAD cross TB vector equal 0 vector. Okay. So we have 3 determinants and then equal 0, 0, 0. All the first row here is IJK. The third row we already calculated because they are the components of the forces. So here I should write the components of FE vector, which is 0, 0, minus 2.4. Here I should write the components of TC vector, which is TC over 3, TC as a common factor, over square root of 3.5. And here we have negative 1 and then 1.5 and then 0.5. Also here we can write TB over root 3.5, negative 1, negative 1.5 half. And in the second row we can write the coordinates of E and D here. Okay, 3.5, 0, 1.5, and for D we have 1 0 1 and also here 1 0 1. Sigma mx equals 0, which means 0 minus 0 here, and then 0 minus 1.5, negative 1.5 over root 3.5 tc, and then we have here cancel this and this, 0 minus minus, it will be plus 1.5 over root 3.5 td, b is also 0 here, which means that they have the same tension. tb is equal to tc, let them be t. Also sigma moment about y equals 0, so we have 3.5 times 2. Negative 1.5 over root 3.5 t, I call it tk, and then also here we have minus 1.5 over root 3.5 t equal 0, and then we can get the value of t. After that we can we can go to the fourth part, which is r vector equal 0 vector. We can write sigma fx equal 0, collect all the x component of all forces. We have here ax, and then ax, and then minus 1 over root 3.5 t minus 1 over root 3.5 t, also minus another 1 over root 3.5 t equal 0. By this way we can get the value of ax. Also sigma fy is equal to 0, which means that ay plus 1.5 t over root 3.5 minus 1.5 t over root 3.5 equals 0, so ay should be 0. ay should be 0, and finally sigma fz equal 0. We have az, and then we have here half and half will be 1 t over root 3.5 plus t over root 3.5, and then minus 2.4 equals 0, minus 2.4 equals 0, so that we can get the value of az. Okay. The question: the pole is subjected to the two forces shown. Determine the components for action at A, assuming it to be ball and socket joints. Also compute the tension in each of the guy wires BC and ED. The required is AX, AY, AZ, TED, and TBC. To save our time, I will write the free body diagram here on the same figure. We just need to draw AX, AY, AZ to represent the first force, which is the reaction at the ball and socket, and then we have TBE here, TBC, and also we have here TED, and we have already two forces F1 and F2. Let's get the coordinates of all these points. The coordinates will be 0, 0, 4, E is 0, 0, 6, and I will call this point G. Its coordinates should be 0, 0, and 8. After this 6 we have another 2 here. For the point C we have 6, negative 4.5 and 0, and for point D we have minus 6 and then minus 3 and 0. Part number 2 is all forces as Cartesian vector, starting from the ball and socket joint A, which has components AX, AY, and AZ, and then look at F1 vector here. F1 vector should be factorized in the XZ plane. It will be 860 multiplied by cosine 45 in the direction and sine 45 in the negative Z direction, so it can be 1 over root 2 here, and then 0, and then minus 1 over root 2, and it can be written as 430, and then root 2, 0, and minus root 2. The third force, which is F2 vector, it has a magnitude of 450. Look at its components well. This is the X component of the force, this is the Y component of the force, and this is the Z component of the force. So to get its X component, we need to multiply it by cosine 20 and then cosine 30, cosine 20 and then cosine 30. For the y component, we need to multiply it by cosine 20 and then sine 30, cosine 20 and then sine 30, and finally the z component is sine 20, sine 20. The z component is negative and also the x component is negative. And then look at the fourth force, which is TBC. For the fourth force, TBC vector, you can write as TBC multiplied by BC vector divided by BC magnitude. BC is C minus B. It will be 6 and then minus 4.5 and finally 0 minus 4, which is minus 4 divided by, it will be 17 over 2, down down up to multiply this 2 here and to write this 4 simply in the form TBC over 17 multiplied by 12 and then minus 9 and then minus. Also for the fifth force and the last one, which we have TED vector, it will be TED magnitude multiplied by ED vector divided by ED magnitude. To get AED, we have D minus E minus 6 and then minus 3 here, minus 3, and finally 0 minus 6 is minus 6. We have here 36, it will be 9 here, so we can simply write it as TED over 3, TED over 3, and simplify over 3 here, it will be minus 2, minus 1, and minus 2. Then we can go to the third part, which is sigma moment about the ball and socket joint to be 0 vector. In this case, we want to get the moments of the first tension here at B, second tension at E, and we can collect these two forces in just one force because they have the same start point G. So we can get three determinants. Okay, we can write RAB cross TBC, and then also RAE cross TED, and finally we can say plus RAG cross F1 plus F2 vectors, okay, equal 0 vector. And now we should construct the three determinants. The first determinant for TBC, the moment of TBC vector, so I can write the third row here now, TBC over 17, TBC over 17, and write here 12 minus 9 minus 8. The second determinant for the second, in the third row here we have TED over 3 multiplied by negative 2, negative 1, and negative 2. And finally, the third determinant for the resultant of F1 and F2 vector. The third determinant will be the moment of the resultant between F1 and F2 vectors. It will be here IJK. This is the resultant of the two forces F1 and F2. And the result is 0, 0, 0. Let's complete the second row of each determinant. B is 0, 0, 4, and here 0, 0, 6 for E, and for G we have, this is RAG, okay, so it will be 0, 0, and 8, right? Let's now get sigma mx equal 0. It will be as the following: 0 minus minus to be plus 36 over 17 TBC, and then the I component here is 0 minus minus, it will be positive 6 over 32 TED, and finally for the third determinant, 0 minus 8 times 211.43 times equals 0. Also we can get sigma moment about y equal 0 by the same way. This is the second equation, okay. We don't need to get sigma moment about z equal 0 because it will be 0 in all determinants, right? 0 minus 0, 0 minus 0, also 0 minus 0 here. And this is exactly as the figure said, because all the forces intersect the z-axis. So there is no moment about z, okay? All the moments of these forces will be 0 also. Okay, we can solve equations 1 and 2 to get the values of the tensions as the following. These are the two tensions. TBC is 205.088 Newton and TED is approximately equal 628.568 Newton. The fourth part and the last one is to write sigma fx equal 0 to get the value of ax, and also sigma fy equals 0 to get the value of ay, and finally sigma fz equal 0 to get the value of az, and they should be as the following. Okay, these problems is enough for ball and socket problems. Thank you and see you later inshallah.